I just wanted to get an idea of who you are, where you come from, what's your background. So I all from Technopark, I all employed. So how many people, how many students? Okay, so I guess all from IIIT MBA.
Yes.
Okay, and okay, what which branch? What is your field of study? Okay, and the others? Data analytics. Okay. Sorry? Cyber security. Okay. Okay. Is there? Okay. Okay. I know there's one guy called Radhakrishnan, sir, right? Okay. Is there anybody who's already working in robotics here? No? Anybody from embedded systems background? Okay. What do you do? Which company? Tata Alexi. Okay. And what's your field of work? Okay. Are you on the hardware side or middleware? Okay. Middleware for in-car entertainment devices. Okay. Okay. Great. So. Okay, so now we have this tech bites and we'll continue.
Good evening all. Welcome to the 65th edition of FAYA Port 80 in association with NASCO. On behalf of FAYA Port 80, I take this opportunity to thank all our previous speakers and also all of you for joining in our mission of free knowledge sharing. We will start with the update session Tech Bites, for which I invite my colleague Sibhi.
Hi all, we'll start our Tech Bites. First slide. Next. Okay. We will launch this new search engine to help the scientists find the data sets. To enable the easy access to thousands of data sets on the web, we will launch the dataset search so that scientists, data journalists, and data geeks or anyone else can find the data record for their work and their stories, or simply satisfy their intellectual curiosity. The engine is in beta form now. Next. Microsoft reopen sources MS-DOS 1.25 and 2.0 codes on GitHub. MS-DOS 1.25 and 2.0 are now available on GitHub for the easy access of the developers after 3 decades. But Microsoft will not accept any pull requests from developers. It will keep as a static copy. Next. Solid to decentralize the web and place the users in control of data. Tim Berners-Lee, who is famous for inventing the World Wide Web, launches open source project Solid to decentralize the web and place users in control of data. Next. Microsoft Robot OS coming for Windows 10. Microsoft has announced the experimental release of the Robot Operating System ROS1 for bringing features like machine learning, Internet of Things, cloud services, and other Microsoft technologies to home education, commercial, and industrial robots. They will be integrating the feature to Windows 10 soon. That's all from Tech Bites. Thanks.
Thank you, Sibhi. Next, we have the relay of the month, getting started with robotics. The session will be led by Mr. Rejin Narayanan. He's a roboticist and serial entrepreneur, and he's the founder of consumer robotics startup Ingen Robotics. And their first product is fully automatic roti making robot, which was designed and developed in Trivandrum. And he has a rich professional experience and has worked in multicultural environments. And he has several paper publications and patent applications to his credit. And he holds a master's in autonomous systems from Bonn University of Applied Science in Germany, and a bachelor's degree in electrical and electronics communication from University of Kerala. and he is a very much a hands-on person with skills in software, electronics, mechanics, and product design. So let us invite Mr. Rejin Narayanan to handle the session.
Thank you. Well, okay, so good evening. I see that some more people have joined. So are you all from Team or? Okay. Okay, so before we start, I would like to have an understanding of what's your expectation from this program. So can somebody tell me what you really expect from this talk, especially somebody who is working, somebody other than the students, because you have taken some of your precious time to come here. So I'd really like to know what is the motivation for attending this talk. Sorry? Oh, okay. And you, the Alexi guy? Sorry, interested too?
Curious and interested.
Okay.
In an intro.
Okay.
I came to know about your product Rotibot from LinkedIn. So I was also curious about that.
Okay, great. We'll talk about that in the second half of the talk. Great. So first let's start off the talk with a small discussion. So what in your opinion is a robot? We'll sort of start from there. So any guesses what exactly is a robot? Because in popular imagination, if you look at films like Ingen, for instance, robot is a humanoid. It's a human. It has human-like attributes. It can talk. It can think. Work with two hands. Walk around. Jump. I hope you have all seen that movie. So Chippy is a robot, which looks like very much like a human. So that is a notion of a robot in popular imagination. But if you look at people who work in the industry, who work in factories, who work in automation, or engineers in general, we tend to think of robots as manipulators that work in factories. Huge robot arms that pick up tires and fix them onto cars, or smaller robots which pick up electronic components and places them on a circuit board for assembly. So the industrial manipulator is for most engineers that exemplifies a robot. But more recently, or purists would argue that it's not really sufficient to have a mechanical device. So why any machine is not a robot? Okay, so that's a pertinent question. So purists would always argue that a robot has to be an autonomous system, meaning it can decide things and act on its own independently without human intervention, and it's not doing some dumb repetitive task. So the definition of a robot itself is sort of I wouldn't say contentious, but there is no hard definition. It depends on how you see robots. And since you, what's your name by the way? Okay, since Rohit mentioned about Rotibot, so that's a new category of robots called consumer robotics, where you have small appliances which do a little bit of smart work, and then they qualify as robots. So now if you ask, is a washing machine a robot? Probably not. But if you ask, what if the washing machine has a fuzzy controller? Then it becomes a slightly tricky question. So, yeah. Okay, so the field of robotics, it affords us the opportunity to reimagine the physical world as we see it. So I think this is one new development that has taken place also because of new advances in robotics, and at the same time for us as engineers, as IT professionals, getting into robotics also allows us to reimagine the physical world in new ways. So I think from my side, that is the motivation for me to come here and talk to you, to get you all into robotics so that we can probably reimagine the physical world. So now I'll tell you a bit on how this is happening right now. So this is a huge truck. You can guess from the size of the driver's cabin what would be the size of this truck. These kind of trucks work in mines. So this one has been running in a mine in Australia for a long time now, for years. This is from Caterpillar. But the special thing about this truck is there is no driver, or a driver need not be there. This is an autonomous truck. So this makes it possible to automate all tasks inside a mine and run an entire mine without any humans around. You know, the loading machines, the trucks, it's all it can all be automated. So this is one way in which we are reimagining the physical world. So this is another very simple example. This is not at all a robot. It's just a IoT device, the Amazon Dash. I think it retails for $5 in Amazon. So what you do is, when you run out of your washing powder, you just press the button, and the next day, or maybe the same day, your courier brings a new pack of detergent. Similarly, this is something many of us have heard and read about. This is a household vacuum cleaner robot. So this which variety of sheets, including you can connect to a GSM network, Bluetooth of things. You can if you want to, but you don't really have to. So on the Arduino website, arduino.cc, there is also a list of or a catalog of projects, including open circuit diagrams, software for constructing a wide variety of projects. So here you see a ball tracking robot, and here you have an arm. So once you get a little bit started with Arduino, this would be a good place to go and try out some real projects. So has anybody worked on boards other than the Arduino? So the one and software do you use? Okay. Okay, many standard robots. Okay, that you mentioned. So along with ROS, we can use normally two simulators are used. One is called player stage. It's a little bit basic thing. Not really. Rotibot is more of a 3D support. So if you want to physically model things, Rotibot is a better but heavier option. So since you asked, the idea is there are many popular robots which are like standards. For instance, we have the Pioneer Active Media mobile robot. So if you load the Pioneer model into Rotibot and do simulations or develop algorithms, basically the same algorithms will run on the real robot. Okay, and then that's the kind of features that these tools like ROS and Rotibot provide. Okay, so assuming that you're all going to get interested, going to buy an Arduino board or some similar board and try out electronics, so that you get started with robotics, I just wanted to give you a few pointers on what could be different from writing regular software. So is there anybody who is not a software developer, or anybody who doesn't know programming here? Okay, and do you know programming? Great. What do you do? Okay, so what do you study? What? Sorry? Okay. Okay. Right. So a small example. So here we have let's say you use some Visual Basic, or so this screenshot is from a Qt app. If you click on the OK button, there is this event handler, on button click. So if you write the software, you can be nearly 100% sure that this handler function will be called. On the console you will get the string clicked, right? There is absolutely no chance that it will not be printed, right? But if you have a switch like this, and let's say once the switch is closed, meaning the contacts touch each other, you have a handler function on switch close. Okay, so now this print closed message, so on the console you will see closed, let's say nearly every time, but there is a fairly good chance that the switch will not work or has gone kaput. Okay, so there is a possibility that you always have to keep in mind that this handler might not be called. Okay, but in terms of software, people never ever think that this handler function will not be called. If you click on the OK button, it will be called. It will be called. So one more thing. So if you push this, if you press the switch, is there any chance that the handler will be called multiple times in area? Properties of these sensors. So you all might have read about autonomous cars and you have seen videos. So most of these cars use a combination of sensors. So one sensor is the camera, obviously, but along with the camera we nearly always use a lidar. So if it is an autonomous car, you can be pretty sure there is a laser ranger. It's called a lidar. Like the blue one here, this is from a company called SICK. So basically what it does is, it has a laser beam which is reflected, let's say typically 180 degrees from left to right, and then it comes back. So you get a laser scan, and depending on the resolution of the lidar, you get, let's say, n points or n measurements within that 180 degree. So this is basically a lidar, and this is a typical scan from a lidar. So by the way, since we talked about MATLAB, this is a basic plot that I made with MATLAB from data coming from the SICK scanner. So if we run, so let's say we mount that scanner on a mobile robot and drive it around. Okay, so what we expect is the lidar will scan the entire surroundings and we'll get a clean map of the room. That's what the expectation. So let's assume that we are continuously overlaying the lidar data. Okay, so let's say I'm driving the robot in a corridor straight, I make some turns and come back, and eventually all the scans, if they are overlaid one on top of the other, you should, at least in theory, roughly get the map of the corridor, right? But this is what happens. So I've driven this robot from this point through this corridor. Okay, so it goes something like this. It goes here, then I turn it, it comes back, and here it takes a few turns and goes and comes here. And if we overlay all the data points from the lidar, this is what we get. But actually the shape of the corridor is not like this. The corridor starts here and ends here. It's a, a regular rectangle. So the reason why I show you this is I just wanted to convey that in the real world things are not straightforward and clean. Signals are always noisy, and you need to make sense out of the data to be able to reconstruct or to figure out things. So the reason why this map is screwed up is in the mobile robot that I used, on the wheels there are sensors called encoders, position encoders, rotational encoders basically. So every time the wheel turns a little bit, the encoder will say, okay, this wheel has turned so many degrees. Okay, so from that I can calculate how much the robot has moved, because I know the robot geometry, the diameter of the wheel, how far the wheels are spaced. So even if the speeds vary, I know how much it has moved. So that is how I found out the position of the robot. Okay, but the problem is the data returned by encoders contains noise. It's not absolute, because the wheels actually slip a little bit. Okay, so the encoder data might suggest that you have traveled 1 meter, but in reality you might have gone only 95 centimeters, not really 100 centimeters. Okay, because the wheels slipped, or at some point there was some water and the wheels slipped a little extra. And every time you turn, this adds up like crazy, because even a small angular difference can make a big impact after you have moved away. So that's why this whole map is sort of screwed up. So the solution to this is, so one classical solution is to use a method called SLAM, which means simultaneous localization mapping. So you continuously figure out, you meaning the robot continuously figures out where it is, and it also figures out what is a map. Both are unknown. So for stuff like this, it's best to go with ROS. Okay, so now I also want to show you an interesting example of mobile robotics. So this is a typical Robocop match where two teams of robots compete against each other. So you see one team has this blue numbers and the other one has pink. They're like this, for example. Okay, so you don't really have to turn like a car. So, for example, if a car is standing here like this and the car wants to go to the right, it has to turn right. But this robot can go to right like this. So that makes it very fast. So one more little example from Robocop. So this blue line, the blue trajectory, shows the path of the robot. So till here, till this point, everything is fine. So once again, the blue line is actually data from odometry. Odometry meaning data from the wheels. And the red line is from MCL. So there's an algorithm, a probabilistic algorithm. It sort of fuses sensor data and gives you a better result. And the green line is ground truth. So there are no real sensors for measuring ground truth. This is actually estimated or obtained by post-processing. It takes a lot of time and you get a much better estimate. So what I'm trying to say here is this blue trajectory up till here, this was very correct, okay? But at this point what happened is somebody physically lifted the robot, okay? So this is the soccer field. Somebody physically lifted the robot from here and brought it over here, somewhere here. But the data from the encoders still thinks the robot is here, okay? Because from that point till the point the robot is put down on the ground and the wheels started moving again, the encoder got absolutely no data. So it still thinks it is there. So the encoder data would say the robot is going here, whereas actually the robot is going here. So this is why we need to have multiple sensors do smart combining of the sensor data and make sense out of it. So now if you think of a self-driving car, this can get very complicated and very messy because there are so many lidars, so many cameras. At certain stages the camera might not see anything, the lidar might see something. At some point when you go inside a tunnel, the GPS might completely black out, and then you have to depend on your odometry sensors or inertial sensors. So making sense of which sensor data to use, then how to combine them, with what level of confidence in each sensor data, this itself is a quite an interesting problem. Okay, so now we will come back to where we left with the Arduino and Raspberry Pi. I just want to show you a very simple robot that we built for the ICFOSS. So ICFOSS is the International Center for Free and Open Source Software. It's based in Technopark. Yeah, same building, top floor, 7th floor, near the food court. Probably, so I think most people miss it because next to ICFOSS is a bunch of restaurants, so much more attractive. So this is a very minimalistic telepresence robot. I think it can't get simpler. Probably it is one of the simplest projects that we have done, but it's also the one which got us the most publicity, interestingly. So now I'll quickly tell you what is inside this. So this is extremely simple. Okay, so I'll start from the bottom. We have two motors. So these motors are here. So this is one, this is the second one, and behind the robot, this wheel, this is actually a free running caster. It's just a caster wheel, like what you have in a chair. It's not doing anything. So the other two motors are driven independently using two motors. So there is no need for any mechanical steering or so if you want to go straight, you drive both the motors at the same speed. If you want to turn left, you turn the right wheel with a higher speed, or relatively higher speed, and other way around if you want to turn left. Okay, so these are the two motors, and here we have all the electronics, and here we have the tablet on which most of the software runs, and of course there is a connection from top to bottom. Right, so basically in the electronics box we have a motor driver board, a battery charging unit, then some voltage regulators, and then an Arduino with a very basic firmware running on it. By the way, all this is open source. You can get all the circuit diagrams, code, mechanical drawings, everything free. And then on the tablet we have Skype running and a Java server. So the idea behind this project was to go in steps. So first they wanted to do the basic hardware, make a platform on which you can add more software and sensors. But unfortunately it didn't go much beyond the first prototype. They asked us, but we are very busy with Rotibot, so I didn't want to take up another project. But it's still open. If there is anybody interested, you can continue working on this. Right, and on the user side, in a PC you can run Skype and a client through which you can control the robot remotely. So basically, let's say if we had that robot here right now, anybody could log in. Why we chose these components? Okay, so this is a very low cost robot built using components that are easily available in India, especially in Trivandrum. Even there is nothing that you need to import or order and wait. So the first choice was the motor. So motors are generally very expensive. So the Robocop robots use maximum motors which cost something like 10,000 or 15,000 rupees. So we didn't want to use an expensive industrial motor. So what we did is we chose to use an automotive motor. But finding the right one was difficult because it goes straight. Of course you can do your control and make it go straight, but it's a little bit complicated. So what we did is we chose a motor which comes in a left-right pair. So this one is used for winding the glass, the window glass up and down. So you get this in a pair, left and right. So that problem was solved. Then we used a motor controller IC which is very popular called the L298. Actually I used this for my bachelor's project, again a robot, way back in '96, the same chip. And then we decided to use dependable low-cost components. Okay, that is the specialty of this project. There is absolutely not much technology in it. Then inside of this black box you have all the electronics and the battery charging circuit. So I already mentioned this. We have the motor controllers, the Arduino. This section is the battery charging unit, and these are just freewheeling diodes to protect the motors. So anybody doing circuit design here? Anybody into electronics, embedded systems? All are software based. Great. Okay, so this is how the board looks like. The motor drivers, Arduino, voltage regulators, and okay. So one option that each of you has now is to contact IC Force. You can get all the code and circuits copy. It's open, and these are some things that we discussed years ago that we would like to have in this robot. So if you're interested, you can just approach them and do it, or suggest something that's completely new. So one idea is to add a lot more sensors with the aim of navigating from one room to the other automatically. So if you want to go from the hall to the pantry, you just tell the robot go to the pantry, and without having to remotely control it, it goes automatically. Another idea was to make it rough terrain so that it can be used as your crops are doing. Another idea was to add some manipulator, like an arm, so it can also do some work rather than just moving around with the screen. And this makes a lot of sense to add ROS so that the other stuff can be done easily. So you're all invited. Okay, so since you're all here with the aim of trying to get into robotics hands-on, I just wanted to show you some pictures of how we actually made this. So the circuit board that I showed you, this one, this is not the first one actually. The first one is, oops, this is the first one. We burned it during trials. So what I'm trying to say is it takes a lot of time and iterations even before you come at a barely okay version. And here you see we are testing the motors and wheels with the older robot that we made, just to make sure the motors will withstand. So even though the IC Force wanted us to make a very basic prototype, so this is where we are trying to evolve a design for the robot that is not too bad to look at. So the original idea was to have a platform, have a tripod or a stick-like thing on top, and place a tablet on the top. But with that outline, coming up with a design that doesn't look ugly is not easy. So what we did is we imagined a human-like creature with two legs which is sort of kneeling down, and that formed the basis for the design. So here you see the knee of the robot, and behind the toes are joined together. That is where the third wheel comes, and this is the trunk of the body. Initially we had hands which looked sort of like cross, but we removed it later on. So what I'm trying to say is even the simplest of things takes a lot of thought and effort. Okay, so I think if we are serious about getting into robotics hands-on, and if you want to do real projects, or at least at the hobby level, the best thing that you can do is to form some groups, form a small group, because getting into robotics is a little more trickier than learning a new software, because you need space, you need physical things, things will burn out, you need instruments. So if there's a group, it's always a lot better. How I can help is I can help you get started, and I can connect you with the right people and the right places. That much I can do. So I strongly suggest, if you're serious about this, during the coffee break. So how many want to do hands-on projects? So I'm not talking about this is not going to be a paid workshop or thing from some groups. I can help you a little bit, and then you do stuff and learn from each other. So how many of you are interested? Show of hands, please. Okay, great. So during coffee break, please connect with each other, so you now know whom to contact. Okay. So now sure. Okay. So let's make study groups and have some coffee. Okay.
We'll have a 5 minutes coffee break. Okay, you can just relax. Take a deep breath. Okay, because you've been, seen by very looking very serious. It's maybe he has taken through a serious topic. That's why about robotics and all. So we have a small quiz. The coffee will be served here. Okay, those who have already been here, who knows how the programs and what all things are there in FAYA Portal. So continued by the same. In between the session, we'll have a small quiz program. Okay, just to cool down. Some sort of a cool down exercise. We'll have a small quiz program. Okay, so I'll ask you a question. Those who know the answer, please raise your hands. Those who are telling the right answer will get a FAYA goodies, FAYA pen. Okay, happy, just smile, yaar. I won't charge you. Okay, so the first question, those who know the answer, please raise your hands. Okay, don't shout it out. Who is the editor of WikiLeaks? WikiLeaks, you know, right? Yeah. No, not Julian Assange. Okay. Any wild guess? Any blind? How many of you have played Loco? Right? They give 10 seconds. So I am also going to give you 10 seconds only. Otherwise you will easily Google. Okay. Recently, Julian Assange has because he is right now. He's staying in he can't move, but recently they have cut down his internet connection. So being an editor, very important to have at least an internet connection. So another person has moved. His name is, any guess? His name is Christine Rafson. Christine, okay. So the pen goes to me ultimately. So next one, definitely I hope you will give some sort of clue at least. Elon Musk stepped down as chairman of Tesla. Yeah. He said that he's going to get the company for the stakeholding for the limited company. It's going to be a limited company. So the stakes went high for 1 or 2 days, and their market agency, I don't remember the exact name. So just like Sibhi, they have some agency. So he told us he is going to privatize the company and not the investors.
Next person asked the same. Please. What's your name?
Hi. Baby.
Sandeep.
Anyway, we got 3 answers, so most of it is something. What was happened is anybody can provide a small brief.
So basically, Elon Musk basically decided to say that he's going to take the company private. He's got, immediately after that, he came back and said that the Saudi funding is not there.
Yeah.
So
Exactly.
so basically the SEC then went back and said, okay, that's illegal, you shouldn't do that. And so now he's under, he had to pay $20 million fine, and he has to step down as chairman. He's still a CEO of
Yes.
Tesla, but he's stepped down as chairman.
Yes, exactly.
Any more details, maybe?
You got everything on the website completely on whatever information you will get from Google. So Sandeep, right? Sandeep is going to get a FAYA pen. Thank you, Sandeep. So question is, Managing Director of India. Yeah.
His son.
Okay. That's just tell them.
No, Suja Chandiya.
Okay.
So we got a directly from the company itself. Okay. So yeah, he's going to get a Thank you so much. The last question. It's a funny thing. Like Apple's iconic white ear were inspired by Apple has got a design with white earbuds. So it's designed which got something so that
Hearing aid. Yeah, what? Hearing aids.
not here. It can what we call headset or something like that. Again, something related to science fiction. Some character, it got the theme or the thing which they've got it from. They got inspired from that particular character. No, not green one. How many science fiction movies? Tell me about some one or two science fiction movies you have watched. Anything?
Yeah, Star Wars.
Star Wars. A character in Star Wars movie. Answer, please. Yeah. Some characters. No. No, then they have instead this thing like what chocolate, something like Kinder Joy recently given that character as a toy along with the thing. Kinder Joy. No. Yeah. Exactly.
Sijil. I am from IBS.
Sijil from IBS is getting a fire pen. Okay. Thank you. Thank you so much.
Okay, so I hope all of you are energetic again after coffee. Have you made study groups? No, probably not. Nobody moved from their seats, right? Okay. So now I want to talk a bit about hardware prototyping in Trivandrum. So has anybody tried to get something fabricated, manufactured in Trivandrum? Anybody from this group try to do it? Okay, I guessed you must have done that. Okay, so Trivandrum obviously is not the best place in the country for this. A better place would be Coimbatore or Bangalore or Pune or Bombay. But so happens that we are here and not in Mumbai. So this machine, it's a lathe that's at the Mitra Niketan Rural Technology Center. It's made in the 1950s. So among the many different machines that we use to fabricate Rotibot prototypes, this is one. So what I'm trying to highlight is, of course, in Trivandrum you find many machine shops with ultra modern, numeric control machines. But what I'm trying to say is, often it's not the machines and facilities that matter. It is the, it's your determination and the kind of human skills that you get, which is really important. And we are very lucky to find many people who are very skilled. So if you want to buy components for your projects, hardware components in Trivandrum, this is the region. It's a 1.3 kilometer long stretch. This region marked in green. Within this stretch, you'll find everything that you can probably get in Trivandrum. So just to orient you, this is the Trivandrum Central Railway Station. This is the Paravangadi Temple. So this part is called Tagaraparamba. Okay. So those who are from outside of Trivandrum. So how many of you are from outside Trivandrum? Yeah. Oh, okay. Maybe all of you. So Tagaraparamba in Malayalam means sort of a junkyard or a scrapyard, but this place is full of shops where you get electronic spares. So this is the place for electronics, and this road called the Powerhouse Road is the place for mechanical stuff. So here you find shops that sell tools, stuff like screwdrivers and spanners and stuff like that. If you go over here in this region, you find power tools, and this is where you will find a lot of shops selling raw materials. If you want to buy stock metal or engineering plastics, different types of specialized nuts and bolts, it's all that. So again, if you want to actually manufacture something, there are a few industrial estates, one at Kochuveli, another one at Papanamkot. So these are places where you will find a lot of machine shops. But the problem with machine shops, as the lone mechanical guy here might understand, is to make a part, you need to set up the machine. Okay. Sometimes you even have to make special fixtures so that this part can be made. And from raw material, every part is made through multiple steps or passes. Okay. So the big shots with the expensive multi-crore machines, they don't want to do 1,000 rupee work. Definitely not, because it takes a lot of time to set up this thing and set up the machine to do this particular thing, and you are giving them only a few pieces. Whereas the main customer for these machine shops in Trivandrum is the Vikram Sarabhai Space Center, the ISRO, BrahMos, and all these defense guys. So compared to them, startups or hobbies are not at all in the radar. We simply cannot be. So what you can do is you can go deep inside the city. Like you can go to a place called Pugamalekil, where there's a small industrial estate and one lone machine shop with good machines. They might agree to do it for you. So that's what we have done. Or you can go to not actual machine shops, but places with machines with good people who might agree to do it for you, like the Mitra Niketan Rural Technology Center, whose mandate is to train rural youth to operate these machines. Their mandate is not to actually do production work, but out of goodwill they might agree to do a few small pieces for it. So this is about the hardware scene in Trivandrum. Plus, yes.
What is the difference between that and Fab Lab? Can you not use it? Can you not use Fab Lab?
Okay, that's a very good question. Have you been to the Fab Lab? Yeah?
Not really, but I've heard about it.
Okay, great. So, the Fab Lab, it's in Technopark. It's at the IIITMK campus. Anybody here has used the Fab Lab? Okay. What did you do there? Very unlikely. Your personal work or official work?
I did a Path Academy course.
Okay. Okay. So, in Kerala there are two main Fab Labs, one in Technopark, another at Kochi. I think it's somewhere near Startup Village, I think. So, these Fab Labs, as of now, don't have machines that can work with metal. Okay. So, for example, if you want to make a part like a coffee cup or a coffee mug out of metal or solid plastic, it's quite difficult to do that in a Fab Lab. But they have a lot of other machines, like they have laser cutters, they have 3D printers, the FDM type. They have a CNC router, so you can work with plywood or even plastic sheets. But if you go to a typical machine shop in the city, somewhere in Karamana or Papanagudi, you can work with a wide range of metals with high precision. You know, you ask the guy to do it with a tolerance of 20 microns. It's normal for him because his regular customer service is he. So, the Fab Lab actually caters to a slightly different crowd, which is the hobbies, the maker, the tinkerer, who doesn't regularly need that kind of materials to be worked. In general, yes. Yes, you can do that. And the Fab Lab, you also have precision milling machines which can make PCBs for you very quickly. Yeah. Okay, so if you are in Trivandrum, one way of getting to know people in robotics is one good way is to get in touch with the IEEE Robotics and Automation Society chapter. So I'm a member. I'm also the former chair. So we have a good group here with people who are really interested in this, taking memberships. Another place is, yeah.
Membership, how much it is?
So it's not much, but you need a basic IEEE membership first to be part of a society.
So how much is that?
So roughly altogether it will be something like in the range of 6,000, 7,000 rupees.
Per year?
Yeah, per year. They're the cheapest option. So there are many options and special categories. Okay, so another place to visit is the Fab Lab, and as he mentioned, there are regular courses being conducted there. So if you get in touch with those people, you get a lot of knowledge also from the Fab Lab fellows and your fellow classmates. Another upcoming thing is the hardware mission, Kerala. So this is a new thing that has been set up by the government, I think maybe a year ago, headed by Dr. Jaishankar Prasad. So their mandate, I think, is to bring hardware manufacturing to Kerala. Okay, so they're going to conduct many programs. So this month they are going to kickstart a series of events called the Tear Down Sessions. So basically what they're trying to do is, since in Kerala there is no big manufacturing industry, there are some like the Thermopent or VKC. There are many manufacturing industries, but we don't have companies that make TV sets or mobile phones or stuff like that. So what KSM is trying to do is they're trying to bring to the people who are interested, so they will take apart existing stuff and try to learn how these are made, how these are built. It's called the tear-down sessions. Another place is the Bosch Rexroth Center for Automation. It's a center of excellence in automation, which runs out of the CET campus. They also conduct regular courses in automation. And if you are a company, you can also request them to conduct, tailor-made courses for you. Okay, but my favorite here. So, how many of you live in the city? Oh, only two. Everybody else is near Technopark? Okay. Sorry? Okay, yeah. So that's a good inference. So my favorite place that I would suggest is the innovation zone. So this is a small lab inside the Science and Technology Museum campus where the planetarium is located. It's very cheap. You take a membership for, it was 1,000 rupees, membership for 1,000 years for 1 year, and you can use all their lab facilities. So they have multimeters, oscilloscopes, 3D printers, computers with CAD software installed. They even have a small desktop lathe, and I heard they are buying more machines. They have a laser cutter now. So that's a great place to be, to hang around. Plus, very close to this place is a Kudumbashri canteen inside the same campus. So, what I have done the past is go there Sunday morning, so you can stay the whole day there, very comfortable, and it's a very relaxed place. There's nobody to push you around or.
Do they take sources for students?
I don't think they have courses yet. But the best part, no, sorry, I'm not sure. But they have some people there who can help you with it, and you can also take your kids along with you. So it's a big plus. So, yeah. Sorry again. Oh, you want to start a student chapter, is it? Oh, you're most welcome. You can contact. You already have an IEEE branch, right? You already have an IEEE branch at IEEE? Okay, I think you might have to start that first. Just get in touch with IEEE Kerala section. Go to IEEE.org, or I think IEEE Kerala section. Just Google it. You'll get the website and contact them. Okay. So this is about the teardown sessions, right? How many of you here are aspiring entrepreneurs? How many of you want to start your own company? Okay. Huh? I see many hesitant hands and some strong hands. Okay, great. So I just wanted to touch upon how to bootstrap. Not only in the context of starting a company, but also in the context of doing your own hobby projects if you want to build hardware or robots. So some things that we have done at Indian Robotics is one. So some of the things that I'm going to say might sound a little weird, but it comes out of experience. Okay. So one thing that we do a lot is we think as much as we can, so that we have to do less. Okay. So think more, so that you have to do less. So there's one joke that goes around about why software engineers are a lot more careless than mechanical engineers or electronics engineers. So if you make a mistake, if a programmer makes a mistake, you can fix it in 5 minutes. Just find out what is wrong, correct it, do a recompile, and your software works fine. So it's very easy to fix. But if you're an electronics engineer, you burn a chip, you have to go to the shop or order online, and then you have to wait, and you have to solder it, and then it's a little more complicated. But if you're an electrical engineer or a mechanical engineer, your life might be in danger, or your machine might burst or explode, or it might harm somebody. So if you are doing a robotics project or a product, it's nearly always a mechatronic thing. You have mechanical, electronics, software, algorithms, in my case food science. So all these are sort of mixed up. It won't be an overstatement if I say also messed up, in addition to being mixed up. So you have to be very cautious. You can break things very easily, and doing things is expensive in terms of time, effort and money. A startup has neither of these. So what we do is we think a lot. Another strategy that we have used is find really good machinists. Okay. So as I said earlier, to machine your components, starting from raw material, there might be 10 different ways of doing it. If you get a good machinist, he'll figure out ways to do it with the cheapest machines, cheapest possible manner, the fastest. But otherwise, they'll go by the standard method, and you'll end up spending a lot more. So another method, another trick that we use is this is also a sort of a generic principle. We try to do as much as possible in software. If it's not possible in software, then you try to do it with electronics. If there is no other choice, you do it with mechanical. So sometimes it happens that solutions to the solution to one particular problem, there might be different solutions. So there might be a solution in the mechanical space or the software space. Sometimes it could be combined. So you slowly figure out what kind of combinations to use so that you keep costs low. Okay, another method that we use is to hire or to train engineers in multiple disciplines. Okay, so for example, we had a guy who would write software and who could also solder components and design circuits. He joined us as a fresher. So having people like these with multiple skills is extremely useful. With two people, we can do a lot of work. So normally it's quite complicated to communicate to a software developer what exactly the hardware guy wants, and vice versa. But if you have people who understand different disciplines, it becomes very easier. So this is one reason why I think people like you, especially the IIITMK students, should learn multiple things. Okay, so don't restrict yourselves to AI or ML or data security. Of course, have your specialization and be experts in that, but it's very important to have a general skill set. Okay, so these are some methods that we have used to keep our costs really low. Another method is another technique that we use is from one iteration to the other, we change our methods, okay, to suit the iteration, to suit the needs of that particular iteration. So for example, I'll take an example from Rotibot. So initially, or in the earlier iterations, we used 3D printing to make our mixers. Okay, so it was quite fast. That was the time when we had to, literally try out hundreds of different combinations of shapes of the mixer bowl, the mixer blade. So it was very expensive to fabricate all these in metal. So what we did is we would 3D print them. That is not really strong enough. So we found a way out. We found an innovative solution. We would get some araldite, which is a kind of a resin and a glue, and smear it on top of this 3D printed part and heat it with a hot air gun so that it gets inside. It's a delicate operation. If you heat it too much, the plastic would bend, and then you get a strong part which you can use to test. Okay, but you cannot eat that because it's not food grade. Okay, fine, we didn't eat it, but we refined the printer. So for that particular iteration, then the important thing was to figure out the shape of the mixer components. We used 3D printing. And later on, the last iteration, when it became very important that we will have many demos and people would be actually eating this, then we went on to stainless steel. Okay, now this is very expensive compared to 3D printing in plastic, but it is now that we need this expensive thing. Till then we didn't use that. Another little idea is to prioritize features and work only on those which are absolutely necessary. So for example, till 2 iterations ago we didn't have the ejector. There was nobody to push the roti out. You had to take it out with a spoon. Because that was probably one of the least I wouldn't say critical, it's very critical for the user, but from a technical standpoint that is one of the simplest features. So it is by using a combination of such methods that you can keep your costs, your burn rate low. So this is one interesting and favorite topic for me. So if any of you have any questions, we can also discuss it right now on bootstrapping, hardware prototyping, entrepreneurship. Yes, please.
Typically, what is the turnaround time for an iteration?
Okay, so this is not only a very good question but also an expected question. So I only didn't know who would ask it. It depends on your iteration. Okay, so why I say that is, so in our case, for example, we have reached the 6th iteration of Rotibot, but for us for us this is actually 6 major iterations. Every major iteration within itself has hundreds of mini iterations. So it is like some small companies you see that every other guy is a VP, whereas if you go to a big company like Apple, even being a manager is a high position. So with our approach, our fastest iteration took, let's say, roughly 2 months, and our longest one took a little more than a year. But this also depends on what exactly you call an iteration, what are the problems that you try to solve in an iteration, and the refinement you have reached. So, I mean, obviously, going from 95% to 98% is a lot more difficult than going from 50 to 60. So but roughly, let's say, I'd be happy if we do it in 6 months. A typical iteration. Yeah.
How do you measure success of an iteration? I mean, do you measure anything? How do you actually get feedback?
Okay. Okay, this is a very good question, but I didn't expect it. Okay. So I must also tell you that I was also in IT and I was here in Technopark programming, doing PHP, Java. My favorite was C++. So in a software project context, especially, you can have all these matrices and you can have all kinds of exotic stuff like Ramachandran's orthogonal defect classification, and you can have all that. But in a startup context, in a fast prototyping context, it's quite difficult to have metrics. So even though many people advocate using metrics, for us it has been very difficult because we started on a greenfield project. When we started, we thought we'd be the world's first robotic roti maker, and we didn't have any specifications. So a related question would be, can you outsource to others? Okay, so it's very difficult because you don't know what exactly you will achieve, but you know what is the ideal case that you want to achieve, and you try hard and you make changes on the day. So at some point you find that it's not as easy as you thought, so you scale down a bit. Sometimes you find it's quite easy, so you go a little further. So it's very, very subjective, and it's very difficult to make a call.
No, I understand that.
Yeah.
But you must have had some kind of criteria, like to say, okay, the roti should be looking like this, or it should taste.
Yeah, right. That is there. So as I said, we go by a list of features, and we of course we have that. It's not that we work open-ended. So we have a list of features. For example, one feature would be the next iteration is going to be 100% food grade. Okay, or the next iteration has all components as SMD, so electronic fabrication becomes easier. So, for example, initially we had a bunch of microcontrollers, okay, controlling each function. So at some point, one target was to combine all of them into one board and write a fancy software to do all that, yeah. Or even before that, even earlier, all the algorithms ran as Python code on a PC, and the electronics was just a dumb front end, or rather back end, whatever. And during one iteration, the target was to move all computing on board. So that kind of feature specific stuff we have, but some things, especially those we are not very so some features will be sort of uncertain, okay, because we don't know how it will be. So there we keep things a little open. There's no
If it looks, you know it when it's there.
yeah, yeah. Or on the way we make a compromise and say, okay, this is not going anywhere as we expected, so let's fix it here.
Only on the robotics or another hardware such that is a specialized detector unit also can is that the approach.
Oh, that's a very tough question. So, are you asking me if I work only on robotics?
Yeah. No, that is
Okay.
that's you work on some different type of defect that sensing
Is that a general question or specific to some product, or
yeah, specific to the product.
specific to my product?
No, what we are doing that
Oh, okay. No, in general, I don't work on sensors or detectors. So as an engineer, I like to work on robotics and projects where there's a hardware software component and multiple disciplines coming together. That's what I like to work on. Some of my past work has been in mobile robotics, robot localization, image processing algorithms and stuff like that. But as an entrepreneur, I must say that it is often an illogical choice. Okay, so this roti making robot was not something that I aspired to work on. Okay, it came to me by chance, and then I had no other way but to do it. So yeah.
So it has been 5 years since you are working on this one robot, right? How?
Yeah. Yes.
So could you please tell your story, like how you became a Rotibot maker, and what made you think about that and work so hard? Because I know that is you had a lot of failures over past many years, and each time that is you again go back and start from the first thing, right?
Yeah.
Many times you have different variations of or different variants of the same stuff that you have created. So you have encountered a lot of failures.
Oh yes.
In between, right? So could you please brief us about your experience and how do you become a Rotibot maker?
Okay. Right. So I'll also take you through a few slides. So I guess we have covered this thing. So before we move on to Vibhu's question, this is slightly out of place but very important. So I thought I'd waited this year especially for the aspiring entrepreneurs who raise their hands. If you are planning to do a startup, so this is a classic slide. You'll find it many places. So there are three things which ideally come together to improve your chances of success. But obviously, there's no guarantee that you'll be successful. Okay, so now we go on to Rotibot and answer Vibhu's question. So I'm also trying to draw from the different topics that we discussed so far. So we talked about hardware prototyping in Trivandrum. So this is one early test that we did. to figure out how we'll be able to build a good mixer. So if you look at the components that we used, this is a parachute coconut oil bottle. This is, I don't know, some plastic cup, and this I knew what shape I want. There was no ready-made thing around, so what I did is I took, I don't know, many sheets of paper, rolled it, and I made it quickly. So the initial prototyping is always quick and dirty. Okay, you can't wait for 1 month for a workshop to do this. So you just do it. You go out, get into the kitchen, find what is there, and do it. Of course, this is one failed experiment. There are hundreds upon hundreds of failed experiments like this. So since you also asked about iterations and how much time it would take, so one unforeseen problem that came up is this. So this interesting pattern that you see, any guesses what it is? Exactly. So this is the this is kind of an X-ray of the coil inside. Okay, but if you use the same hot plate to make a roti by hand, you'll never get this pattern, because the human, you have the human in the loop. The human brain comes into the control loop, and you are turning the roti, flipping it over, and you'll never get this pattern. But if you make a machine, one thing that you have to solve is, do you have any idea what the solution could be? Okay, so one solution would be to have a robot arm or some manipulator that will move it around, but that will be too complicated for a home appliance. Another solution would be to sorry. Okay, that goes to a different type of heating. But one solution could be to do a pucker thermal design. We have done that. We have done finite element modeling and analysis and came up with a perfect hot plate where the temperature variation would be less than 5 degrees. But then you could miss the brown spots, right? Because the brown spots on the roti are very important if it has to be appealing. Otherwise, even if it is cooked, people think that it is not cooked. So yeah, so the solution is quite complicated. Yeah.
You could just about
sorry again.
You could just above so it doesn't touch the outlet directly.
Okay, that will amount to baking it in air. That's a slightly different problem. So this is a thermal image taken using a thermal imaging camera. It shows the temperature gradient. So see, there is roughly a 50-degree variation in temperature. This is a commercial 2000 rupee roti maker hot plate without the Teflon coating. We removed the coating and let it heat for a long time and did a measurement. So the point is, because we have a human in the loop system, you don't realize the bad effects of these. So okay, I think I'll answer Bigu's question and come back to the next slide. So how all this started was, so I had started this company, Ingen Robotics, in early 2011. So first I thought we'll build a revenue stream. We'll have projects coming in, the regular drilling. On one side you have projects coming in, money coming in. On the other side you build products. So I had a 6-member team doing projects in embedded software, image processing. We had a few clients, and not everything was good. We were making some money, but the product was getting nowhere. So we wanted to make a SCARA robot. So I don't know if you know of this company called Shastra Robotics. They have similar, not exactly the same. They have something like that. So what happened is this product was getting nowhere, and we were getting bogged down by the projects. I was working day and night on C# and middleware and hardware and whatnot. It was not really going where I wanted to go. And during this time, so I think the background was set. Okay, I had my own company. I had expertise in robotics. I could work on electronics, mechanical, software stuff. So all the background was set. And one fine day, my wife asked me to help her in the kitchen to make rotis. It was a simple task. I had the rotis flattened out. I just had to put it on the tawa and bake it. So this is the point where all this started, fortunately or unfortunately. and I found this a very boring job to turn it around and not do anything, just stand there in front of the hot tawa. It was very boring. So I was thinking of a method to reduce my boring time, or I wouldn't call it drudgery because this is recorded. So what happened is I wanted to make a 5 tawa attachment. Okay, so I wanted to have 5 tawas obliquely on the stove, so that I can make 5 rotis at a time. So my time gets reduced to 1/5 of what it. So I was thinking of this. I was about to go to a workshop and talk to the workshop guy on how this can be done. And at this time, one of my friends, a big boss, he came to Trivandrum. We met at Kaudiar Coffee Day. Casually, he was drinking coffee and he made a very casual remark. He said, Rejin, if you can make an appliance that makes any Indian food at the press of a button, then you have hit a jackpot. So somehow this stuck to my mind and stuck in my mind, and the 5 tawa roti attachment and this machine idea, this sort of merged to form what I called at that time the chapati printer, naively. So this is how all this started. And then for 1 year I was just thinking about this, not doing anything, but this idea was bugging me. 1 year later I drew the first sketch. Then we ran it as a side project. We did some virtual modeling, tried to refine the idea, make it suitable for a home appliance. Then we did it as a side project. We made the first prototype, which was a disaster. We threw it away. The mixer got stuck the first time. It took 20 minutes to mix dough for 1 roti. Then we did iteration of iteration, improved things slowly one by one, and now we have a fully functional working prototype.
So it is not easy to mix this chapati dough, right? So adding water and all this. So
Yeah, that's true. That's a very relevant question. The problem is every kind of wheat flour absorbs a different amount of water. Okay, we don't realize it because we naturally automatically feel it with our hands when we mix, and we add the right amount of water. But how does the machine figure it out? So initially we use the fixed quantity of water and fixed quantity of flour. So it works for that particular flour on that particular day. But the next day, if it rains or if it's very sunny, the humidity changes and there is the humidity change in the flour and the whole thing goes for a toss. So eventually we developed some algorithms which works with sensor data to find out what is the right amount of water to add and what is the right amount of mixing to be done. So this is one core part of the product, and we have a bunch of patents surrounding this whole thing. And yes sir, please.
This started as a passion.
This that's what I said. It didn't really start as a conscious, so given my background in mobile robot localization and working with lidar and all that, I think I should have gone and do some autonomous driving or things like that. But
see, we all have some kind of a idea like this that sparks in the mind sometimes.
So that
how to go about it, like the revenue model, because it's not, if it's something that can be written with a program and 2 hours, then that doesn't cost much. But this is something like you did it for 1-2 years, or I don't know how much time you spend on that, and the cost that you put yourself, or was there any funding from outside to complete this?
So
I'm not asking about the how much you spend on that.
I understand. So far it is largely funded by myself. Of course my friends have also helped me, my friends and family, but otherwise we have not taken any external investment till now. But right now we are in a stage where we should find external investment.
There are something like Indiegogo and all where people ask the prototyping and
Yes, that's one option, or we could go for a venture capitalist or even a angel investor. So those are options that we have just started exploring. Yeah, but the first part of your question, so this thing actually happened sort of by accident, and it's also, I think this is, it sounds a bit weird, but I think this is more of an artistic expression than a technical project. Okay, so for example, when I'm telling you that robotics is interesting, exciting, go out, buy an Arduino, go to Tagarapamba or go to Innovation Park, Innovation Zone, do projects, I'll help you. So that is our conscious this thing. But this idea, it's like a thing that has to be expressed, So it's a little hard to even say it, but I have to do it. There's no other way. There's no other option. So I don't. So for example, I didn't know CAD modeling or mechanical stuff. So probably he would understand it's a world of its own. But I learned all these myself. So I went to a workshop, found a good machinist. I learned milling and turning and how to use tools in the workshop. Because otherwise, when you interact with people of that discipline, they immediately figure out you don't know anything, and then the discussion goes nowhere, right? So when you go to the workshop, they'll ask you what tolerance and is it a first angle projection or whatever, and a host of other things. And if you don't know anything about this, then you're gone. So similarly, at one point we reached a stage where food science knowledge was very critical. Okay, so I went to the Central Food Technology Research Institute in Mysore and did a short course in baking science and technology, and that's where I really learned about the science behind wheat flour. It was an unforgettable experience.
So my question really was like, if you did this of your own, then what about the work in the company that you were started? Like
okay.
There were other clients also, right? So how much time did you put on this project?
Okay, so at one point this thing became serious. Rotibot became serious, and we decided to stop everything else. Everything. So from that point onwards, zero income. We are 100% focused on this, and I think so. Of course, you can always debate whether this is a good idea or it can be successful or whether people accept it. All that is debatable. But one thing I'm very sure of is the one and only one reason why Rotibot reached this stage is one, because we decided to focus on that. So from that day onwards, every day, day after day, we have done nothing but that. So I think that focus has been very critical. Yes.
What was your runway when you started? Like how much time did you give your?
So as I said, this was not a
When you focused your company on this, how much time did you say as a company we spent before we say okay, you now want to do that?
Okay, we had a runway of let's say 2-3 years in terms of financials, but I thought this would be over in 1.5 years, which looking back was sort of dumb. Yeah. Okay, so I'll go to the next slide and then we can. Okay, so as I said, at one point I didn't know CAD, and we reached a stage where I wanted to make one proto very fast, in a month if possible, and I really wanted to get it done as soon as possible. I couldn't wait to learn CAD and do all the fancy stuff. So what I did is I went to a shop, bought some thermocol sheets, some masking tape, and one fine evening I sat down on the floor with a paper knife. I cut the thermocol sheets, stick them with masking tape, and see how it looks and think if it will work. And if I feel it doesn't work, then I'd cut it with a knife again, stick it back again. It was a very nasty way of building a model, but I did it, and one full night I had this. The next day morning, without sleeping, I took to the workshop and told my special machinist, "Sir, we want it done in 1 month." He said, "It's impossible." I said, "No, we'll make it possible." we did it sort of. So based on this, we made our second iteration, and that's when we that's when we made the first eatable roti. This is the mixer assembly that's used in our recent prototypes. One reason I wanted to show you this is to tell you about how we used laser cutting and acrylic sheets to make parts rather than use 3D printing. So for example, this is an acrylic sheet, and this from here till here is actually a stack of sheets, and each layer is of a different thickness and is of a different cut. So this is a quick alternative to designing a complex machine part and molding it. And compared to 3D printing, this can be much faster and a lot more stronger. And these parts are all machined, turned out of food grade plastic now. Yeah. And this sort of shows how our mixer design has evolved over time. So initially we were working with metals, then we realized it's very expensive, time consuming. Then during these stages we stuck to 3D printing. So we did hundreds upon hundreds of iterations. This is just a small representative set. To give you an example, when we shifted to our new office in Technopark, we sold our old parts and some of the old prototypes. It was something like 100 kilos of, old stuff. So this is our fifth prototype, but this was very tall, and it's difficult for a typical housewife to reach on top of the dabba where you have the wheat flour. So we worked on reducing the height, and this is the last one that we have in our office now, in good working condition, and yeah, we can eat rotis made out of this. Yeah, so this is where we are. Yes, I think we are come to a close. By the way, this is my my former professor, Professor Paul Kluger. He's a mathematician and roboticist, and people in this trade are all a little bit hands-on. Huh? You can't stay away from the real hardware. Yeah, so now if you have any further questions, yes, please. Yeah.
Having the microcontrollers, the diodes, transistors, all those things.
Okay.
And then we go at the side.
Yeah. Where we had a few different boards, right?
Yeah.
No, it's a different slide. This one.
So the one that you assembled.
Ah, okay. This one?
Yeah.
Ah. Okay.
So looking at this slide, I look at the diagram like I need to think how to pull from these diodes to the transistor biasing, figure out the values of the resistors. All those things will come to my mind when I see the schematic, right? So how can this is the circuit diagram of the first
okay, this is from the telepresence robot TR7. Yeah.
If I am to get up and running, at least one slide for it. Do I have to go about drawing all these things so I can be able to grab all of a sheet or something like that?
Okay. So in the beginning, I would say get a shield if you can. but in the long run, it would be very useful if you can do it on your own, because that'll give you really a lot of confidence. So if you're doing it at a hobbyist or a maker or an academic level, I would say at some point you should try to do it on your own. It's not that complicated, especially in circuits like this. There are very few analog stuff to be figured out. It's mostly digital or on-off or PWM or DACs and ADCs which are ready-made. It's not too much of math. Really, trust me, it's not too much of math. Yes, please.
I think there's software for this also.
Yes, there is.
You can use Spice or something to actually come back to the actual values.
Sorry, are you referring to Spice for circuit simulation?
No, I mean, this again, I have very basic understanding. So
okay, we
may not be using the right word, but or the right software. But there should be software that would help you with this design.
Yeah, that is true, but I think circuits of this complexity don't really need a prior simulation. You can just do it and it won't go wrong. It's not that complicated.
When I used to do that, the main issue was
okay. Okay. I think that would be a very focused and narrow topic to. We can also take it offline. But my general comment is, once you decide on, or once you're focused on getting something done, okay, then you'll do all this automatically. You don't have to worry about it too much. It will come at that time. You'll find, I know, you'll Google and understand and do it. It is not really necessary that you understand everything very deeply before you start. It's sufficient if you have a concept level. So this is my personal opinion. Are you a teacher or a student or a? Okay. Okay. So your teachers might not agree with this. So how I do is, as a practitioner, is I make sure that I have a conceptual understanding of things very broadly, okay, or a range of subjects and a range of devices. I make sure I have concept level understanding, and whenever I need to get deep knowledge, I Google and figure it out. Otherwise, if you try to learn everything very deeply, it will take a long time to finish your learning, and then you always run the risk of forgetting things. So, yes, sir. Sorry, which stepper motor? Yeah, but which slide? Ooh, okay, it actually depends on the type of stepper motor you use and the application for.
That's why that how much minimum area of
sorry, I don't remember offhand. I'm not very familiar with that. So I haven't used stepper motors in, I don't know, 18 years. Sorry, I have no idea.
Nowadays, the chapatis are available to ready to eat for afternoon.
Yeah.
And even chapatis are available for 2 weeks. May you know who is your customer for Robot?
Okay. So the main customer for Rotibot. By the way, how many of you? I'll answer this. How many of you have seen a video of Rotibot? None. Anybody seen Rotibot in action? No. Okay. I think I have a video. I'll try to play it. Okay, so I'll answer this question. What's your good name, please? Okay, Hashim. So Hashim just asked, does it make business sense? So that's roughly speaking. Okay, so let me quickly also explain what happens here. Here you have wheat flour, water. This is the mixer. So it does three things. It mixes the flour, it kneads the flour, and it shapes the flour. And here you have a press plus baking thing where the roti is baked. Now it will take a minute to cook, and then it will be ejected. Okay, so who is your customer? That's this question. I think the upper middle class is the customer for this machine. Okay, so basically people who are working couples who don't have much time. So if you look at cities like Bangalore or Bombay or Pune, if you take a typical working couple, by the time they reach home after traffic jam, it's already time for dinner. So they either eat out or order food from a QSR, or eat some minimal food, or they have a maid, but it's a little complicated. So machines like these, I think, will come up very quickly to address this gap. And if you consider people who are say 30 plus, they are often very health conscious. Okay, so they want the whole thing to be very hygienically done. So they are not sure if the pre-packaged roti was cooked properly, or your cook washed her hands well, things like that. But this solves many of those problems. Plus, how many roti eaters are here, in the sense, how many of your rotis is staple food? Anybody from the roti belt? For you also? Okay, great. Okay, so in many states people eat roti for lunch and dinner. It's very normal. So for people like that, it's very important to have, or it's very good to have fresh hot rotis, rather than packaged rotis which you reheat and doesn't taste like the freshly made one. So even in this machine, even though we have not got the opportunity to tune it much, tune the quality of rotis much, even today, if you eat a fresh roti, it definitely tastes better than what you eat from a regular restaurant. Am I right, Deepu?
Yeah.
Okay.
So I was actually surprised. I just went to his office and he just told that I will cook you a roti, and I was thinking it will be something taste like roti, but it was really awesome because it is really tasty as well as it was very soft. So and he just added some honey and gave it to me. So I was just expecting he will bring that Rotibot here. So that so people can taste it.
Okay. Yeah, maybe I should have. Maybe I should have.
So I actually told my team that is you will be bringing Rotibot and you'll be keeping it here for a couple of days.
Okay. Okay. Sure. I'll bring the next version here. You can have it for it.
Pre-order for that.
Yeah.
Yeah. Okay. Okay. Great.
Are you thinking of any industrial applications?
No. The reason is, one, it's already an existing sort of saturated market. There are machines that can make thousands upon thousands of rotis per hour, like the one in the Golden Temple in Amritsar, for example. They have a huge machine for the langar. Second thing is, my personal problem in my house, cannot be solved by that industrial machine. And because I'm also an entrepreneur, okay, there is this passion and this need to express my thing, but eventually I also need to earn my roti. So Rotibot as a consumer appliance has huge scale, which is sort of lacking in the industrial or QSR thing. Of course, it can be an excellent business, but the real scale of an appliance like this is as a consumer appliance. Yes.
So, it will automatically remember the date between the machine.
Oh. Okay. A very insightful question. So right now it doesn't clean, but it's very easy to clean. So that's what we have done. So the the white part which did the mixing, you can take it out just like any normal mixer, and it's very easy. That is very easy to clean if you keep it in water for 2 minutes. It's you don't even need soap or detergent or dishwasher to do that. And then we have some Teflon coated plates which you can wipe with a wet cloth, because it's Teflon, nothing really sticks to it. So that's it. You can actually do it in less than 2 minutes for sure. The only thing is you have to wait till this thing cools down. Yes.
So a couple of things. One thing is, yeah, I really like the fact that we can make the roti without oil.
Oh yes, very keen observers.
Second thing is, so are you thinking of other types of roti like stuff, like like orati or any other kind of breads that you can make, Indian breads?
Great question. So when we started working on this, okay, so once we decided, okay, let's do this roti making thing, naturally we also made a list. I said, okay, roti, kulcha, naan, this and that. But the thing is, as a startup, as an entrepreneur, I didn't want to spread out my attention and focus. So we said, okay, let's choose one thing that is most commonly used, commonly eaten, and then do that well. And once we figure that out, then we'll attack everything in parallel with, of course, the right resources in place.
So you should take orati. Is it rice flour and water?
Okay, now all of us know what is your favorite gadget. It's already okay. So let me say one thing. With this kind of mixer, we cannot do rice flour. Okay, so this works with flours that contain gluten. So without gluten, this configuration doesn't work. But definitely, this is something that we can think about. Looks like a logical progression, right? Yeah. Okay. So we have not figured out the actual cost yet, but eventually, when this comes to the market, I hope it will be in the 25 to 30 K range. Still a bit expensive. It's probably going to be the most expensive appliance in the market. But for people who like to calculate ROI, if you look at cities like Bangalore or Pune, you have housemates who come only to make rotis. They charge you 1,500K per month. So I don't know, maybe in 2 years or something like that, you get your ROI. Plus, there is nothing like getting rotis on demand, anytime, 24 hours. Hygienic, without oil. So what the thing is, once you start eating this, okay, every time you get a cold roti, you unconsciously compare with that experience. So it's so once you use it, it's a compelling product. Yes. Okay, so right now we have that blue container which has water, but of course we will also provide a water connection. So if you want to connect it to your water supply, it comes automatically, right? Like your washing machines.
What about the salt?
Okay, people are very keen. One person asked about oil, the other about salt. So the roti that Deepu tried didn't have so in many places they don't add salt, and normally nobody eats a roti just like that. They eat it with some side dish or a main dish, how do you call it, right? So if you don't add salt, normally nobody would even realize it. That's one thing. But if you still want to add salt, you can mix it with the water. That's an option. It's comparable to the electric roti makers that you have in the market right now, which you operate by hand. So it's roughly comparable.
I hope
right.
Rotibots are completed. Your project, this Rotibot already completed, right?
So we have an advanced prototype in the office. we'll soon start a pilot, very small pilot batch. So things like this don't get to a point where it's complete. You're always improving, and that's non-stop innovation goes on. But we have all the basic concepts in place. Now the things that we have to do is industrial design, especially the looks part of it, and design for manufacturing and assembly, which is sort of so mechanical design and electronics design is always tailored to your production methods, your manufacturing volume. So we need to make changes accordingly. So there is still a lot of work to do. Yes. Yeah.
Or starting this company.
Thanks for that.
So I think will be the last question. Actually, that's almost answered.
You were working as a software engineer.
Okay, so I think, I mean, really, that's why I'm here, and that's what really binds most of us together. I was a software guy.
What made you take this daring step, like go from a software background to a hardware background? The entrepreneurship in hardware.
Vivo, that is not only the last question, but it's also going to be a long question. But I'll try to compress it, compress the answer. So since childhood, I was really interested in tinkering and making things. I take apart toys, try to put together, take motors and make fancy small fans and toys. So I was into all that, and some of my father's friends had a company in my native town, Kollam. I think it was called Systems and Devices. They used to manufacture TV boosters. That was a time when you had long
antennas,
half as tall as a coconut palm. So they used to make boosters and fuel-saving devices for Premier Padmini cars. I don't know if you've seen those cars. So since my childhood, I've been seeing such things, people doing companies and making new products. So as a friend of my dad, Prakash Uncle, he had a radio TV service shop. So I could go there during vacations, and so even after my 5th standard, I could use multimeters. I knew what a transistor is, what a diode is. I could do very simple resistor calculation. All the BB Roy stuff I learned in school. So electronics was my hobby at school, and I came to engineering by choice because I really loved the subject, not because it was a status symbol. So during my BTech also, I did a robot as a BTech project. It was funded by the state government actually, a mobile pick and place robot. So always at home I was connecting my PC to electronics and writing C programs to control stepper motors. Very long ago, so I don't remember the step angle actually. I burned my PC ID cards. Those days PCs had separate ID cards. So because of all this background, after doing software services for a long time, I decided to get back into research. I did a master's in robotics, came back, and then I was doing this company. I started Ingen Robotics. So that's what I was saying some time ago. This problem came to me at a time when I was really prepared, sort of, not fully, but at least partially. So many things have to come together if you want to do this. So for example, a normal software guy, if his wife asks him to make rotis, either he will scold her or he will do it.
Software solutions to do the same.
But the point is, as I explained, it's quite easy to get into this. It's not too hard, and if you are willing to try, I'd be more than happy to help.
Thank you.
Just one more thing, like you had a recent visit to Israel, right? With that. So is there anything that you want to share from that experience that you gained from there? Something.
Yes. Okay, so the Kerala Startup Mission and the Internet and Mobile Association of India, together they took a delegation of small companies plus some big companies to Israel to learn from their startup ecosystem. I found that it's very interesting, very exciting. I think Indians need to learn from their work culture, their go get it attitude, no nonsense attitude. For example, it's very difficult for an Israeli to say yes. They always say no. Not always, but they tend to say no. But when they say yes, they really, really mean yes. They're going to do it. But for us, it's the other way around. We are too polite, too humble to say no on the face of somebody. We'll always say yes, sir, ho jayega, and then. So many such nuances like that. One thing that I really liked is they have compulsory military training. Everybody, boys 3 years and girls 2 years. So I think that sort of instills in them a sense of pride and a sense that they have to do something for their homeland. And I found that girls can walk around late in the evening with no fear. I think one reason could be this military training, because if somebody tries to mess around, she's been a soldier for 2 years. So I like many other things apart from startups also. And I went there expecting to hear a few gunshots, but I heard none. It's a very diverse country. They have very orthodox Jews, very liberal, moderate people, 25% Arabs, by the way, which came as a surprise. They have no resources, no natural resources. It's a desert, but yet they have drip irrigation everywhere, plants, and it's an amazing place. I think they flourished because they were sort of they had to go through very difficult life situations. So it's a very interesting place, and I find that they are technically very innovative. We went to the Tel Aviv University incubator. One startup guy came and he talked about his drone company. When he came in, he said, "My friend will join me soon." And after some time, he said, he asked the guy sitting at the corner, "Can you please open the door because my friend is waiting to come inside." And then I thought, what does he have a handicapped founder, co-founder? Then this guy opened the door, and a very small drone came inside, flying, and he showed his hand, and the drone came and landed on his hand, switched off the rotors, and after some time he said, he gave a voice command asking it to go back by name, and it flew back. So we have seen many such amazing stuff like this, including companies who work in cybersecurity. We met some investors. We went to an event called the DLD Fair. I met an international author who wants his book to be published also in translated and published in Malayalam also. I've connected him with DC Books. And I think overall it's a great place for technology, and there should be more connections, I think. Thank you.
Thank you so much, Rejin. So it was really an insightful session, and it was really amazing and amusing to hear how you landed into robotics and how Rotibot came up and stuff like that. So one thing I felt over here is that if anyone, not from this community, anybody, if you are into robotics or if you want to know about robotics, or if you're into building something, you have someone to look up to, or you have someone to seek for help. So that is really a good thing. So as a token of appreciation, I invite our Managing Director, Mr. Deepu, to hand over a certificate of appreciation. Yeah. I also invite Sibhi. So she is in charge of the Fire Potati committee of this month. So I invite her to hand over a memento to Mr. Rejin. So Deepu, if you would like to add something.
So actually, thanks, Rejin. I think that is you have been very busy these days, and that is taking time out and coming here for a session and sharing your knowledge. Okay, and actually that is what he has built. There were many IoT startups and many other people who had made a mark. They went and saw his product, and what they were telling is that they feel themselves ashamed to say like they are into robotics, just because that much effort has been put in building that Rotibot. And surely that is, I expect like that is in coming future, that is it will build a new business model. Even just like having coffee machines there can be Rotibots there where you can go and have a that is take out rotis in from public places or something of that, just like ATM machines. And then even mobile applications can be connected to it. That is, you can just tell like that, yeah, I need 10 rotis or something. The possibilities, the opportunities that this Rotibot bring to place is just like it's really big. And so this is just a beginning. And like that is, we may have there is actually robotics, whenever it should be a workshop. This is just like a knowledge sharing thing, just to connect you to some people or some places where you can start working on it. And we may have more sessions on that part. Okay. And how many of you are new to Fireport 80 coming here for the first time? Okay. So Fireport 80 is something that happens on first Wednesdays every month. And this is the 65th edition, right? It has been there for the past 5 years, more than 5 years. And like we have a Facebook group as well as Facebook page where we keep updated with the events that we do. Every month people come together just to know about some trends or trending things that is happening around, and it happens on first Wednesdays in Trivandrum, second Wednesdays in Kochi, and third Wednesday in Kozhikode. And that is, they will be sending you a feedback email. Please do share your feedback, and it is all about creating speakers from our local community. And if you want to take a session on some topic, if you are interested to do that, please do connect to us. And hopefully, I think like somebody from this crowd will be a speaker in upcoming Fireport 8. Thank you.
Sorry, Vibhu, So one last thing, since many of you wanted to do some hands-on stuff, Vibhu, can we have somebody here organize a group so that I know somebody can give a email ID or a phone number, WhatsApp or whatever, so that you can.
Yeah, we can create a group. That if you want to create a community for this, then we can start that. We can create a what? I think everyone has given your phone numbers, right? We can create a WhatsApp group, and those who wish to be out of that, because there are a lot of WhatsApp groups, so you can feel free to do that. But
yeah. Yes, or if somebody from this group is already willing to take the lead, and I don't know, you or I think that would be the best way to go forward.
And it will help you to keep connected and have more hands-on sessions. So there were having many such small communities that started from here, and then it is just like that community can work by itself.
Yeah, sure. So that's it for the day. Thank you, Rejin. Thank you for coming down to office and sparing so much of time and effort to make the session a big one. And thank you, each and every one of you. You have taken your precious time and come down to our office. So as Deepu said, do share your honest feedback with us, and also share if you have any specific topic you would like to discuss. So we can arrange a session for that. So, and not only that, if anybody of you would like to be a speaker in any of the sessions, it may be Trivandrum, Cochin or Kozhikode, you can just connect with us. So thank you so much.